Hello, my name is Greg, and I am a tutor with Chegg Tutors, and today we will be covering a pretty basic topic of gravitational potential energy. So, as you know, if you're taking a physics course, there are different types of energy. There's kinetic energy, electrical, and there's potential energy, more specifically gravitational potential energy. And the formal definition of gravitational potential energy is the energy of an object based on its position in a gravitational field. So it's a pretty basic idea. So in a gravitational field, that could be on Earth, that could be on Mars, could be on the Moon, could be on the Sun. Any object that has essentially a gravitational field can support potential energy. So the best way to teach this would be just to do a simple example. Let's see here. But first, let's go over the equation. Of course, we have U, which is usually the variable, the letter that they use for potential energy. That equals mgh, which is the mass times the acceleration due to gravity times the height of the object from what your point of interest, from either the surface of Earth or from some other surface. So potential energy equals mgh. In most cases, your h will be the height from the object to the ground. So let's see here. We have let's say we have a box with a mass of 2 kilograms being held up in the air at 5 meters. And if we are on Earth, that means that the acceleration due to gravity is 9.8 meters per second squared. On Mars, that value would be a lot less. On Jupiter, that value would be a lot stronger. So let's find out what the potential energy is. So what is U? And from that equation, we had U is equal to mgh. Excuse my handwriting. And we have all of these variables here. So we have U is equal to mass of 2 kilograms multiplied by the acceleration due to gravity. So 9.8. Let's rewrite that. Meters per second squared multiplied by 5 meters. And that equals, let me grab my calculator really quick. I apologize for that. So we have 2 times 9.8 times 5. And that is equal to, obviously, I don't know why I need a calculator for that. Wasn't really thinking. It's equal to 98. And the unit for potential energy is the same unit for any kind of energy, and that is joules. That is the SI unit. 98 joules. Joules, spelled like this, just in case. Joules. And the variable, the letter that we use to write out that unit is capital J. In other problems, you'll see a problem like this. This is a really common problem where you have some object on some kind of hill, and then you want to find out what the potential energy at the top, so then you can find out what the kinetic energy is at the bottom, or vice versa. So here again, this is just you really just want to use the same equation. There's no numbers here, but just to let you know, just the different applications of gravitational potential energy. It would still be the mass of the object times the acceleration due to gravity multiplied by the height above the ground. Again, we have this block of mass m at a height of h. So again, you can just use U equals mgh, and that will be your gravitational potential energy. So that is it for this video. If you have any questions, please feel free to message me. Link to my profile is in the description. And if you have any questions or you're unclear about anything, again, please feel free. I'll be happy to reply to you and to help you out as best I can. Thank you. Have a good day.